Hey everyone, welcome back to .NET Developer. My name is Venkatesh and I'm a technical consultant at Microsoft. If you have been following us so far, you know that we are creating a series of videos on the Semantic Kernel and Azure OpenAI. As part of these videos, we have already covered some basic things like how you can deploy your models and some of the basic prompt engineering techniques and also the important LLM parameters. So now this is the right time that you should start your learning journey on the semantic kernel. Today I am so excited to share with all of you that I have come up with a learning path for the semantic kernel where you can start from the beginning and you can understand all the building blocks which are offering by the semantic kernel. Without a further delay, let's get started. Yes, these are the very important building blocks of the semantic kernel learning path. I have curated this learning path in such a way that even beginners should be able to cope up with the process and should be able to understand each and every building block in a simple way if you are following in a sequential manner. In this entire learning path, you should be very good at with all the building blocks which I have mentioned here. The very first thing is a basic prompt, which is where you will be able to interact with your LLMs with a very simple manner. There are multiple ways to perform this in a semantic kernel, and I will be walking you through all of these types in our videos. And then next thing is the functions. The functions are very important blocks in the semantic kernel. Using these functions, you will be able to provide the external data to the LLM to answer your questions. That can be your domain-specific knowledge, or that can be any website data, or whatever it is, whichever the data is not available with the LLMs. So there are multiple ways to create a functions, and there are multiple use cases for these functions. We will explore each and everything in a detail and wait for that video as well. And then we'll be continuing with the. So in this plugins, there are multiple inbuilt plugins are already available out of the box, which you can directly use in your prompting. Otherwise, you can create your own plugins that can leverage the functions as well and other external data sources. That we will see in a detail when we explore the plugins part. And then very important thing in this entire learning path is planners. So the planners are kind of an orchestrator which will be using all of this knowledge which we have learned so far in the all the building blocks and then performing the complex jobs that usually LLM cannot be done. So wait for this planner, that is very important thing. You'll be mostly end up using that in your production like scenarios. And then the semantic kernel team is working on a couple of experimental features. I'll be walking you through them as well, and also I'll be sharing with those links with you as well, so that you can learn all those concepts on your own pace. And in this video, we are going to start on the very first section of this learning path, that is basic prompt. Let's see how you can use this basic prompts with a semantic kernel. As I have mentioned before, we will be covering our very first section of this learning path, that is our basic prompts. So as part of this video, we will be covering what are the different ways that you can execute your prompts against the LLM using our semantic kernel. And if you have ever used the ChatGPT or Bing Copilot Chat, when you have requested for any response, the response will be prepared word by word. That is nothing but the streaming process. In this way, you can improve your user experience by engaging your user. And also, if you have followed us, we have covered a couple of LLM settings that you should be tweaking to change the way the LLM has to respond. I will be showing how you can use the semantic kernel to actually work on those LLM settings. In our very beginning video, I have explained how you can get started with the semantic kernel and Azure OpenAI. So in that video, I have explained the process of execution, so how the semantic kernel will work. If you have any doubts there, please go and watch this video so you can understand like how the execution will work. If you have any doubts about the deployment of the Azure OpenAI models, I have created a separate video for that one. Please go and check that. As of today, I am recording the Microsoft Semantic Kernel version is 1.7.1. First, I will be installing these NuGet packages. Then I will be importing all the namespaces that required to perform this basic prompt. So these are the important namespaces that you should be importing. And then using this .NET env package, I'm just trying to load all the important key values present in the .env file and storing them into the respective variables. And then next we have to create our semantic kernel builder. So this is the way that we can create your semantic kernel builder. And then using that semantic kernel builder, you should be able to add the functionalities that you want to use. So in this case, I have used the Azure OpenAI Chat Completion API. So to enable this again, you must need this deployment name, API key, and the actual endpoint. So as I have already mentioned, I'm loading them from the environment variable and storing in this particular variable. So I'm just and then passing those variables in this constructor. So by this time we have our well-built kernel. Yeah. To demonstrate this capability, I just came up with an example. So if you ever wanted to learn any new programming language, there should be a proper learning path, explore each and everything in a sequential manner. I'm trying to simulate the same thing with this example where I have prepared this prompt template so that LLM should be able to help us to prepare our learning path to learn any new programming language. For that, I have given these instructions how that LLM has to work while preparing the learning path for that specific programming language. I'm passing that programming language using the string interpolation. And also, I'm providing these output instructions like how the output has to come out from the LLM. Then, as I have mentioned earlier, so you should be able to tweak the LLM settings in order to get the responses the way that you are expecting. So to do the same thing with the semantic kernel, you have a couple of classes that you have to use. So for that, you might need to use this OpenAI prompt execution settings. So for now, I'm just mentioning the max tokens as 500. That means so LLM will give us the learning path in a maximum 500 tokens or less than that. And I'm using the temperature as 0.1. That means I want more accurate data. And then I'm providing the system prompt. So as I mentioned in our past video, the system prompt is nothing but a persona for the LLM. So I'm defining all the personas and how it has to explain. Then you have to use these execution settings and create your arguments. And you will be using these arguments while we're actually passing this basic prompt to the LLM. Now let's see how you can actually use this prompt template and this LLM settings to get the learning path from the LLM. So using your kernel builder, you have to use the invoke prompt async API, and this method will accept the prompt template and also your arguments. And there are a couple more overloads that you can try with, but for this example, I'm just going very basic. So I'm passing the prompt which I have prepared to this method and also the arguments. So once this invoke prompt async method completed, you should be able to see the learning path coming back from the LLM. So I have already executed that one. So after the execution, this is how the LLM has responded back. If you have noticed here, I'm just taking how much time it took to complete this invoke prompt async method. If you consider this time too long, that means your user experience is not good. To improve your user experience, so you might need to use another method where you can simulate the process in a similar way how the ChatGPT is preparing the response in a word by word. That is nothing but the streaming that we will see now. In order to use the streaming mechanism, Semantic Kernel is providing you another method where you can use that method to simulate the same experience. So that is nothing but invoke prompt streaming async. So this is expecting the same arguments. I'm passing the prompt and arguments, but it will give you the token by token to you. Once the method started executed, then you have to keep appending the token generated to the word by word so that you can show the entire response back to the user in a different way. So in this method, the advantage is the responses keep creating word by word. You don't need to wait for the entire completion of the response. That will definitely improve your user experience. Let us see in action how this invoke prompt async streaming mechanism works. So let us run this one. If you notice this, the very first token that generated will be in a very less time. But later onwards, we will be just taking those each token got generated and we'll be appending that to the actual string. So that user will feel that the response was very continuous and it was very interactive. You will see this is how it will be happen. So that is how the invoke stream mechanism will work. I hope now you have a clear idea when you have to use this invoke prompt streaming mechanism method and the other one. So it really depends on your requirement. Then let us see what are the different ways that the prompt can be executed in a simple way. So far we have seen one way of executing basic prompts with the help of semantic kernel, but there is another way which is more helpful when you are actually developing the production-like scenarios, where instead of keeping all the prompts within the code itself, it is very important to isolate these prompts from the code and keep them in a separate locations. That is where the second approach comes into the picture. You will be taking all of our prompts from the code and keep into the text file and store them in a separate location. And we will actually use those text files to load the prompts into the LLM. So this is how it will be happening. So first you have to create your own text file and keep all the prompts that you require. Since you are working with a text file, you can actually inject that specific input variables into a specific location of the text. So there is a concept called magic variables. Please go and watch our first video where I have clearly explained how these magic variables are working. So this is how you can create this magic variables. I'm just mentioning that I'll be expecting this programming language as a input variable while actually executing this against to the LLM. So once you're ready with this prompt, now let's see how you can actually use this text file. This is a very basic thing how you can actually read contents of the text file. Once you read all the contents of the text, please store them in some variable like prompt text. Then as I mentioned, you have to deal with the magic variables. In order to pass those values to the magic variables, you have to rely on the kernel arguments. We have already created this argument object where I can use this arguments object to include those magic variable contents. So I'm passing the user input here inside this magic variable, and then the rest everything will remain same. You have to use whatever the methods, whether it is streaming or non-streaming, and pass on the text and the arguments. So rest everything will work in the same way. That is the only difference between these text files and the prompts. With this, we are done with the first session. Now let's have a quick recap what we have learned so far in this session. So we understood that we have actually prepared our learning path, and we started with our very first section of the learning path, that is a basic prompts. And inside the basic prompts, you understood that how many ways of actually invoking the LLM with your basic prompts. And then there is a difference between the streaming and non-streaming, that also we have understood. I hope now you are in a right situation to choose a better method for your particular requirement. Hey, wait. Don't forget to hit that subscribe button because we are creating very valuable content in this area. So if you want to stay up to date with these video sessions, please make sure you subscribe this content and also hit that bell icon to get notified on our new videos. And thank you for watching these videos. See you in the next video. Until then, keep innovating with Azure OpenAI and Semantic Kernel.